Okay, so the idea is to talk about secret sharing in cryptography. We will talk about there are different schemes for secret sharing. We will talk about Shamir secret sharing and additive secret sharing. So secret sharing is if I have a secret, for example, I don't know, a password, what I can do is um, use some methods to give different, to divide the keys to unlock the secret between different area, different people, different shares. The word is shares, such that I will need the secret won't be in one, or the keys won't be in one place, and they will be more safe. And I will need to bring together those shares in order to get the secret. For example, the secret to the bank, the secret to the password, the secret to the something. So you understand that I need to give some shares to different areas, different peoples. So the different schemes build different ways to use those shares and divide those shares and use those shares to get back the password or the I don't know what. And we will talk about those different schemes. The first one will be Shamir's secret sharing, Shamir's scheme, which is based on a polynomial. What will happen is that maybe I will do paint. What will happen is that we will create a polynomial. We will create a polynomial. I don't know. It depends on how many shares we want to need to reconstruct the password in order to know what degree of polynomial we want, because we will reconstruct the polynomial. Now, if you remember, to reconstruct a polynomial of degree, for example, n, I need n plus 1 points, right? So, for example, if I have a polynomial that is like this, so the degree of this polynomial is degree of 2, so it's a degree of 2, and the secret will be that if you take that polynomial and look at the value of the polynomial at x equals 0, here the value of the polynomial here will be the secret that you are looking for. Here will be the secret. The value here will be the secret. So all we need to do to get the secret is reconstruct this polynomial and take the point at x equals 0. This is how we will get the secret, the value secret that we want. The value at x equals 0 is the value for the secret, is the secret. So here is 0 point, or the secret. So the value here is the secret. So how will we reconstruct the polynomial? How will we know which polynomial to use? This one, or maybe this one, or maybe this one. So the idea is that the shares will tell me how to reconstruct this polynomial. For example, for this polynomial, I will need 3 points on the polynomial. For example, here, this is a point. Let's call it x1. It has a value. The value of it will be y1. Here I have another point. Let's call it x2. And it will have a value, y2. And as you understand, I need 3 points because this is a polynomial of degree of 2, and I need 2 plus 1 points. Each point that I'm drawing is a share. Namely, I need at least 3 shares. I can give more. If you want, I will just, for the sake of example, will give more. Oh, this is 3. So I need 3, but I can create more shares on the polynomial. But the idea is that we will need 3 shares in order to create, again, the polynomial based on reconstruction of polynomials. Again, remember the rule. For polynomial of degree n, we need n plus 1 uh, dots on the polynomial, and each dot is a share. So don't I want to give the share, I want to give a share at x equals 0, because if I will do that, I will just give the secret. So I'll give here is a share, so one people will have x1, everyone knows x1, but y1 will be available only to the one that uh, having the share. So x1 everyone can know, but y1 only the one with the share will know that. x2 y2 is another share, x3 y3 is another share, x4 y4 is another share. Now I need, from all the shares I have, the number of shares I need to reconstruct the polynomial. Again, is the degree of polynomial plus 1. So for the Shamir, I need to know what is the degree of polynomial, what is the threshold. Let's call the threshold the number of shares I need. So I need to know the threshold, which is 1 more than the degree of polynomial. I need to know the threshold in order to know how many shares to take to create the polynomial. And if I know how many shares I need, I will know the degree of polynomial, just one less than the threshold. Okay, that the threshold is the number of shares I need to reconstruct the polynomial. So those are the shares that I create. Here a point, here a point, here a point, here a point. What I do in order to get those shares, I take the secret, I create a polynomial that I want from the degree I want, and I create him with random coefficients, but at x equals 0, I make sure that the secret is the value. So I can make it a x squared, and a will be random value, plus b x, again b will be a random value, but plus c, and this c will not be random, because this c will be the secret. This will be the value that the polynomial will intersect with the y-axis. This will be my polynomial. Let's call it, I don't know, p of x. This will be the polynomial of degree of 2. So I need 3 shares. So in this polynomial, after I define this random number, after I define this again randomly, and this not randomly, but put in the value of the secret, I will get, after I do that, I will get a polynomial. And from that, here will be the secret, and from that, can take somewhere 3 points, not in the x equals 0, 3 points, 4 points, 5 points, however I want, but I need to know how many I need for reconstruction. Create the number of shares I want, each one is x and y, and distribute all the points as the shares, and tell what is the number of shares you need in order to reconstruct the polynomial. This is how Shamir's scheme is working with polynomial. So after I get the shares, for example 3 shares, I can reconstruct the polynomial this in degree of 2. If I have a polynomial degree of 3, I will need 4 shares. Degree of 5, I need 6 shares. Okay, so after I get the number of shares I need, I can reconstruct the polynomial, for example, in using Lagrange interpolation, for taking the points on the polynomial and reconstruct the polynomial. If you remember Lagrange interpolation. Now, the advantage of creating more shares that I need is that if some shares are getting lost, I still have enough shares to reconstruct the polynomial. So this is one of the advantages of Shamir, because I can create more shares that I need. So if one gets lost, nothing happens. Now, another important security feature of this is that if I know one shares, it doesn't tell me anything about the secret. It doesn't tell me anything about anything else. It's just a number on the polynomial, and no one knows yet. The one that holds the share doesn't know what is the polynomial, because he only has one share, and he doesn't know what is the degree of polynomial. So maybe if it's a polynomial degree of 2, one point of the polynomial can have many polynomials going throughout this point. Usually we are doing it in a finite set just for you to understand this, but I won't use it too much here. Okay, so this is how we hide the secret in the polynomial in x equals 0. This how we create the polynomial, random, random, and the secret. After we create the polynomial, we just decide what is the degree, and based on that, we know how many coefficients we need to choose randomly. After we create the polynomial we want, we can take points from it, that will be the shares, and distribute the shares however we want. Using the shares, the threshold number of shares we need, we can reconstruct the polynomial and then look at x equals 0 to get a secret again. This is the idea of Shamir's scheme. And how can we reconstruct the polynomial? Using 3 points, for example. For polynomial degree of 2, we can use Lagrange interpolation. So, okay, this is a Shamir scheme for secret sharing. Oh, this is not looking good. Okay, so let's look at it on a more specific way. Okay, so this is an example with real numbers. So we have a secret that we want to use Shamir to hold it, so no one will know, and there will be shares, and you will need shares to create that. So we have a secret for a safe, for example. So this is the secret, and we want to hide it and share the secret using sharings. So use Shamir. Now the Shamir will tell me on those numbers how many shares I will need to reconstruct the polynomial. Here 3, it means that I need 3 shares to reconstruct the polynomial. It means that the polynomial is degree of 2. The threshold is 3. We need 3 shares to create a polynomial of degree 2. Now this other number 5 here is just a number that we created, which tells us how many shares to create. We will create 5 shares, and you understand that I don't need all of the shares to reconstruct the polynomial, because again, if I need the threshold is 3, I need only 3 to reconstruct the polynomial. So let's see how we create. We want 3 shares, we want the polynomial of degree 2. Because again, the degree of polynomial is threshold minus 1, and the threshold is here. So this is the polynomial. This is the polynomial of degree of 2. And our secret, this one, will be in the value here in C, because this will tell us in x equals 0, this polynomial equals C, and this should be the secret. So C will be the secret 7349, and no one will know that without reconstructing the polynomial. Okay, and in the end, I want to show you something. In the end, here, in the end, we will create a polynomial. This will be our polynomial. We will plug in x equals 0. Here is the plugin, and we will get the value in x equals 0, which will be the secret. So this is what we will do. So this is the polynomial of degree 2 in that example. The secret will be in the value c, and we will choose a and b randomly. This is a random choose for a and b. So the polynomial will be this one. This is the secret, and those are a and b, which are randomly chosen without any, just randomly. Okay, so we will create shares. Again, to create the shares, we need different points on the polynomial. So we'll just take different points on the polynomial. We want 5 shares because it's here. So we will take x equal 1, calculate the value of the polynomial of x equal 1. This is the first share. The second share, which is x equal 2, calculate the value of the polynomial x equal 2, which is this one. X equals 3, calculate this one. X equals 4, as you can see, we don't need all the shares. It will help us that if a share is lost, we still can reconstruct the polynomial. F equals 5, again, get the value. Okay, so we have 5 shares. x and its corresponding value, x and its corresponding value, x and its corresponding value on the polynomial that we created. Now, to reconstruct the polynomial, when we will want that, we will take three shares, for example, the first, second, and third. Those are the three shares. In order to reconstruct this share, and we need to know that the polynomial is, we need three shares, and we know that because this tell us what is the threshold to create a polynomial. Okay, so let's see, in order to create a polynomial from these 3 points, we will use Lagrange interpolation. So just for showing you the Lagrange interpolation, so we want to take 3 points and reconstruct a polynomial of degree of 2. Threshold minus 1 is the degree of the polynomial. Polynomial of degree n needs n plus 1 points in order to reconstruct it. Remember this. So we use Lagrange interpolation. Remember the interpolation of Lagrange, which the general formula for this is x minus xj divided by xi minus xj for each lix. So we calculate lix. This is second point, this is third point, 1 minus 2, 1 minus 3. This is first point, this is third point, 2 minus 1, 2 minus 3. This is 1, this is 2, 3 minus 1, 3 minus 2. That's the third point. So we get those three, and we implement the value y times each of them respectively. Yes, for this one we are taking this and multiply. This one we are multiplying with this. This one we multiply with this and getting f of x. Now we want to find the value of the polynomial. In order to find the secret, we want the value of the polynomial at x equals 0. So we plug in this x equals 0, and we will get here for each L, if we plug in x equals 0, we'll get a value, right? For example, for this one, x squared of 0 is 0, minus x 5 times 0 is 0, plus 6 divided by 2, which is 3. Here is the 3. We plug in 0, which will give us 3 minus 1, which is minus 3, minus 3. Here we plug x equals 0, which will give us 2 divided by 2, which is 1. Here is the 1. Each one of this, again, is multiplied by the corresponding point. This for the Li1, this for the Li2, this for the third Li3. Plugging it in, we get a value at x equals 0, which is the secret. And this is how we used Shamir's scheme to create the shares and to use the shares to reconstruct. We create a polynomial at x equals 0. The value of the polynomial will be the secret. We said what is the degree of the polynomial. It tells us what is the threshold we need, one more than degree. Then we create shares. We created more shares than we need. We need threshold number of shares depending on the degree of the polynomial. When we want to reconstruct the polynomial to get to the polynomial to get the secret, which is in the value of the polynomial at x equals 0, we take the number of threshold shares we need. We can make more shares than we need, more shares than we need. It will help us if some shares will get lost. We take them, use, for example, some interpolation, for example, Lagrange interpolation to reconstruct the polynomial. After we reconstruct the polynomial, we get the value at x equals 0, and this is the secret. Okay, so this is the secret sharing using Shamir scheme. Now there is other schemes, and we will do, for example, the additive secret sharing. So let's see an example. This will be a more simple scheme, and the idea of this simple scheme, file, new. Okay, you got this. This is for Shamir, quite nice. Polynomial, the x equals 0 secret, points for sharing that we created, polynomial that we decided on the coefficients randomly except for c, which will hold the secret, which will be here the value, and reconstruct to get p equals 0, which is the secret. Each share is this, another share. We can create more share than we need. Okay, you got it? This is Shamir scheme for secret sharing. Now let's move to additive, which should be more simple. Additive secret sharing, which what it will do if we have a secret, for example, equal 10, what we will do, and now we need to create exactly, or we will need to use all the shares we create. What we will do is take shares, which will be a numbers. For example, this is 3, another share, which will be, I don't know, 1, and after we create the shares, we create another value, which will be the secret, which will be just as the secret, which is 10. Let's call it let's call it SE so we can know what I'm talking about, which will be the secret value minus S1 minus S2. You see that even here, the one that hold the secret don't really have any idea what is the secret. I mean, if someone look at it, like in Shamir, if someone have this share, he doesn't know anything about the secret. The secret can be any number. He doesn't know what is the value of the secret because he doesn't know, for example, the value of the secret. He doesn't know, should not know the value of S1. But even if he know part of it, even if S1 knows S2, they don't know what is the S3, for example, which is the secret minus the two other S. So in order to know the secret, you need all the shares. And if you have just one part of the shares, you still don't know the secret. This is also true for Shamir. If you know part of the shares, again, if they are not more than the threshold, less than the threshold, if you have number of shares less than the threshold, it doesn't tell you anything about any other share or about the secret, and this is very important for security. So we divided the secret for shares, and then in order to build again the secret, we need to do a sum of all the shares. Again, here compared to Shamir, we need all the shares. We need to use all of them. We can, if one is get lost, we can't reconstruct the secret. So this is one of the problems, of the disadvantages of the additive secret sharing, because we need all the shares. We cannot rely on part of them. In Shamir, I can create more shares than I need and then take just a subgroup of the number of shares for the threshold to create a polynomial. So Shamir can have shares that are backups. And here we can't. We need to use all the shares that we create, because the idea is that the last share is just what I need left using all the other shares in a sum in order to get the value of the secret. So I need all the shares to create the secret in additive secret sharing. So this is a disadvantage. So yes, this is how additive secret sharing works, and let's see the example they gave me. So here we have a secret number 10. We will share the secret. We create shares with 3 participants and equal 3. And again, we need all the shares to reconstruct the secret. And we are splitting. Share 1 get 3, share 2 get 2, and share 3 will be the secret minus S1 minus S2. So those are the shares that we have S1, S2, and 3. In order to reconstruct the secret, we need to sum all the shares. 3 plus 2 plus 5 is 10, and then we reconstruct and recover the secret. You will see that it's much simpler than Shamir that uses polynomials. Here we don't, but here we have problems. As we said, no threshold. You need to use all the share that you created, and if one is lost, you are in a real big troubles because you cannot reconstruct the secret. Shamir can create more share than he needs, so if one gets lost or two gets lost or whatever backup he get, what size of backup he created, he can get away with only the threshold number of shares. So let's just compare Shamir and additive secret sharing. So threshold in Shamir is adjustable. As you saw, I can create more shares than I need. In additive, I need all the shares. Security is strong and additive is quite weak. Complexity is moderate because I need to create the polynomial, and the polynomial at x equals 0 is the secret, and the shares are points in the polynomial that are not at x equals 0. And I need to interpolate after I take the shares, the threshold number of shares. I need to interpolate using Lagrange interpolation to get the polynomial and then calculate it at x equals 0 to get the secret. In the additive secret, it's much simpler, just summing the secret. We take the secret, create some shares that their sum is the value of the secret. We have reliance to loss good at Shamir. He can create more shares than he needs, so if someone gets lost, he can get away if he still has enough shares to reconstruct the polynomial. Again, you need threshold number, which remember that the number you need to reconstruct the polynomial, you need degree plus 1 point on the polynomial, which should be, I think, just one. I think that one thing that you need to remember, that if you take 3 points but they are collinear, namely one is the multiplication of the other, it will be a problem, because think of it, if I have for a polynomial of degree of 2, I need 3 points in order to reconstruct it, because it's degree of 2, so I need 3 points, 1 plus the degree. But if all the points are collinear, that may be a problem, because think of it, think of 1, 2, 3. You can take this second degree polynomial throughout it. You can take, I don't know, this second degree. I think that they should not be collinear. Let's see if I'm right. The points, the shares in Shamir should be not collinear, otherwise the polynomial won't be unique. Now, for example, 3 points that are collinear don't define a definite second degree polynomial. I think that this is something that we didn't talk about. In Shamir secret sharing, the points representing the shares must not be collinear. If they were collinear, then multiple polynomials of the same degree could pass throughout those points, making the secret a non-unique and destroying the security of the scheme. So yes, they should be non-collinear, and in collinear we mean that one point is a scalar multiplication of the other, right? Give example for collinear and non-collinear. So I just want him to give me a coordinate, but rather to the points line of the same straight line. Scalar multiplication of coordinates, no coordinate. Multiplication of the other. Okay, so let's consider 3 points. 1, 3, 2, 5, 3, 7. Note that the slope between any 2 points is the same. Oh, so you need that the slope will be different. So the slope between the 3 is the same. So they are lying on the perfectly straight line. No, not the scalar multiplication. Not only. In Shamir context, if they represent shares, multiple lines could pass throughout them and the secret would be ambiguous. Non-collinear, this point do not lie on a single straight line. There is no single line equation that fits all 3. They are non-collinear. Only one unique quadratic polynomial can pass throughout these 3 points in this plane. So we need to take a non-collinear points, because if we do take collinear points, we may cause something that is ambiguous. Okay, so this was about Shamir scheme and additive scheme for secret sharing. Shamir using the polynomial, using the x equals 0 for secret, using shares as points in the polynomial, creating a polynomial where c in the polynomial is the secret and a and b are decided randomly. Non-collinear points for share, you can create more share than you need. Threshold for the number of shares you need. Good for if there is something shared that get lost, and more complex using Lagrange interpolation or something to reconstruct the polynomial from the points. And additive secret sharing, which is more simple, but you take the secret and divide it to shares. The sum of the shares is the value of the secret. Remember that there is and this is a problem, because if some of the shares, one of them even get lost, you don't know the share. Remember that a person that get a share doesn't know anything about the other shares, so this is a security importance, not in Shamir and not in additive. In Shamir and in additive secret sharing, having one share doesn't tell you anything about other shares or the secret, unless you only have one share. So if you have one share is enough. But of course, if there is only one share, there is no share in the one share. So let's consider it that we need more than one share. Yes. So for example, in Shamir, it's not a point polynomial, and in additive, it's not a one number share. I mean, it's not that we shared it to only one value. Okay. So having one share doesn't tell you anything about other shares or the secret, right? So here, an additive solution, assume the schema implemented correctly, having only one share reveals essentially no information about the other share or secret. Only if the secret share schema implemented correctly. Having less than the threshold for creating the secret, but more than one share also doesn't reveal anything about other shares and the secret, right? Because not that just one share, even if you have two shares or three shares, until you get to the threshold, or until you get in Shamir, or until you get to the number to the all of the shares in additive, it doesn't really tell you anything. If you enter the share number of shares in Shamir, significantly reduce the probability of recovering the secret, but it doesn't guarantee absolute information hiding. There is a difference between revealing nothing and revealing particular nothing. Okay. Uh, if you have fewer than the threshold number of shares, you cannot reconcile the secret. You have some points on the polynomial, but not enough to uniquely define the polynomial or its y-intercept. Where you cannot determine the secret, this is partial information is not completely useless. It reduces the number of possible secrets. Although the space of possibility remains large, the amount of information gained is negligible. A brute force attack trying all possible secrets would be computationally impractical, even with multiple sub-threshold shares. This is even more straightforward with additive secret sharing. Having any number of shares less than the total number of shares provides no information about the other shares in secret. The shares are completely independent. Okay, so the idea is that generally, if you have less than the number of shares, you don't know too much. Here it tells you that you know a little bit more chance that the polynomial will be, for example, if you have 3 shares but the threshold is 5, you know that if you didn't get to the threshold, you at least know that it's not, I don't know, a second degree polynomial of this and this, I don't know. Okay, so this was about secret sharing in cryptography. We talked about two schemes, not all the schemes, but just two schemes, the Shamir scheme with polynomials and the additive scheme with the summing of the shares. Thank you very much, and that's it.